Hey math kids, today we're going to look in section 2AC and we're going to talk about average rate of change. So first off, just like the concept, let's talk about that. So in previous classes you graphed lines. We talked about slope. We had a few things like y2 minus y1 over x2 minus x1, which can be thought of as delta y over delta x, or rise over run. All of this stuff is the same thing, and that's all referring to slope. Now, in this class, we're going to be focusing on different types of functions. So for example, this one's exponential, but we could also talk about this with a parabola. Okay. Now, if we just look at a piece, so let's say we just look from here to here, and we make that into a line, that slope, which is just an average slope, it's not the exact slope, we can see some of the green poking out right there, and then if I even exaggerate this a little bit more, so if I do it on this one, see how it's like kind of the same slope, but this dips down a little bit more. So like the slope right here is actually steeper than the pink slope, but the slope right here is less steep. And so this is just like an average slope between those 2 points. We call it average rate of change. So we have average rate of change, which is just like slope. So I think if you just think of it as slope, it's not going to be too bad. So let's try a problem. We're going to have this, and I'll just draw something like that. 1, 2, 3, 4, 5. 1, 2, 4, 5. Okay. So let's say the problem asks us to find the average rate of change on the interval from -2 to 1. What we're going to do is go on the x-axis, mark -2, mark +1, and we're only going to look at those 2 points. So we could find the slope between those 2 points, and I'm going to give us that value. So our rise is 1, and our run is 1, 2, 3. And so the average rate of change on that interval is 1 over 3. Rise 1, run 3, and that's all it's asking us right there. Now, another way they could ask us average rate of change is by giving us an equation. So for example, they give us f of x is equal to, let's just say 3x squared plus 2x plus 1, and they want us to find the average rate of change on the interval from 0 to 1. So what we're going to do, we're going to note that these are both x values, so I'm going to call this x1 and call this x2. So I'm going to plug in 0 for all of the x's. So 3 times 0 squared plus 2 times 0 plus 1. So 0 squared is 0 times 3, that's just 0. 2 times 0 is 0 plus 1, so that ends up being 1. Since this was an f of x or a y value, that actually gave me my y1 value, which is going to be 1. Now if I plug in the second one, so 3 times 1 squared plus 2 times 1 plus 1. Once again, I'm plugging in my x2 value, which is 1, for all of the x's right here. 1 squared is 1. 1 times 3 is 3. 2 times 1 is 2. Then if I add all those together, I get 6. And so my y2 value is 6. Now at the beginning of this video, I reminded you guys of this slope formula. And we're just going to plug in the values to that. So my y2 value is 6. My y1 value is 1, so I say minus 1. My x2 value is 1, and my x1 value is 0. So if I simplify that, 6 minus 1 is 5. 1 minus 0 is 1, or the average rate of change on this interval is 5. Okay. If we were to graph this and then do a line that goes from the x value 0 to 1, it would have a slope of 5. Okay. I think the last thing we need to talk about is just if we have a table of values. So let's say we have some time values, and then we have, let's say distance. And let's say our time is in hours, and our distance is in miles. So time, we have 0, 1, 2, 3, 4, 5, 6, 7. And then we have 100, 150, 170, 190, 250. Let's see, how are these lining up? 300, 310, 405. Okay, so we just have this data that'll be given to you. And what if we want to know the average speed in miles per hour? So we want to know average miles per hour. So to do that, we would just we're essentially just going to do y2 minus y1, x2 minus x1. So right here would be the y2, right here would be y1, this would be x1, and this would be x2. So we just find the difference between the y's. So we're going to say 405 minus 100, and then the difference in the x's, 7 minus 0. And so 405 minus 100 would be 305, and then 7 minus 0 is 7. So we go to our calculator, and we do 305 divided by 7. So we get 43.6 miles per hour. So on average, they were going 43 or 44 miles per hour. I'm not going to be really picky about how many decimals you do, just as long as it's within reason. Hopefully that's enough to get you through your assignment, but if you need additional help, come to Math Lab, and for now, calculator.